Welcome, geometry students, to the homework help video, page 221, numbers 15 through 40. Let's go ahead and get started. Here we go. Okay, the directions say here too. Let's see, label the cities Fayetteville with an F. So let's put an F right here for Fayetteville. And there's an F, and we're going to label Fort Smith with an S. If I can find that somewhere, S. And H for Hot Springs. So here's H. L for Little Rock. So here's L. J for Jonesboro. So here's J. And P for Pine Bluff. So here's P. Okay. And then decide whether each statement is approximately correct. So here we go. LH from here to here is congruent to LP. Is that approximately true? Yes, it is, definitely. So the answer would be yes. Okay, number 16. SP bisects angle LSH. So here's LSH. So here's the angle. That's a really bad angle, but there's the angle LSH. And then SP. Does SP bisect or cut that angle in half? Well, it looks like it to me. It looks like that this angle here would be congruent to this angle here. So I'm going to say yes. Just an estimation, but I would say yes. Okay. So, yes. Okay, number 17 is JH congruent to JP. I would say no. It looks like JH is a little longer, so I would say no to that. JS bisects angle PJF. So here's P to J to F. So here we go. That angle there. Okay, this angle here. Does JS bisect it? Here's JS right here. Does that look like it bisects it? No, it does not. It does not look at all like this angle here is congruent to this angle here. So I'm going to say no. It does not look like it bisects it. Pretty simple so far, guys. Pretty cut and dried. Alright. Is SP, here's SP, perpendicular to PJ. Here's PJ. Looks like it to me. We're just going with the naked eye, just giving it an estimation. I would say yes, though. And then lastly, does FH bisect SL? So here's SL right here. And does FH bisect it? Well, here's FH. That actually looks pretty good, students. Let me show you why. Watch this carefully, okay? Look. Remember, in order for FH to bisect SL, it doesn't have to be perpendicular. It just has to go right through the midpoint of SL. And that looks really close to the midpoint to me. Okay? So I am going to say yes. Now, you might feel differently about that. but to me, that looks like FH is passing through the midpoint. That's my opinion. Okay, so yes. Okay, moving on to number 21. As point P moves from here to here to here, what happens to AP? Well, let's see. Here's AP. Here's AP. And then here's AP. And then when P moves up to here, here's AP. Well, to me, it's very obvious as point P moves this way up this line, all of these segments are getting longer. So it increases or gets longer, okay? All right, number 22. What effect does moving point P from here to here to here do to this angle here, angle APB? Well, first of all, let's find angle APB, okay? Here it is right here, okay? APB. Now, students, think about it. Let's use an extreme to prove a point, okay? Let's pretend that P moved all the way up to here, okay? Look how little this angle's become here compared to how big it is up here. Do you see that? So it really is common sense as P is moving up this line, this angle is getting smaller and smaller. So whatever it was here, it's smaller here, it's smaller here, and it's smaller here. So what effect does moving point P up this line have on this angle? It's causing the angle to decrease or get smaller, okay? Okay, moving on to numbers 23 and 24. As point P moves from P1 to P2 to P3, and B moves along with it from B1 to B2 to B3, what happens to the length of BP? Well, that's really simple, guys. Look, here's BP, here's BP, here's BP. Each line is getting longer, okay? That's pretty simple. Increases. All right, getting longer. Now, number 24. How are segment B1, P1, so here's segment B1, P1, and segment B2, P2, and segment B3, P3 right here. How are they related? Well, students, we know they're parallel. Mr. Arrowhead, how do you know that? Because we learned a theorem that said if two lines are perpendicular to the same line, then those two lines are parallel. Okay? And notice that all three of these lines are perpendicular to the same line. So all three of these lines are parallel. Okay? They are parallel. Okay, moving on to number 25. Okay, here's the goal right here. Here's the goalie. Okay, and here's the puck right here. And here's the guy. My great drawing skill is about ready to hit the puck. All right, now let's see here. When the puck is at the other end of the ice rink, the goalie is likely to be standing on line L. How is L, line L, here's line L, students, right here. How is line L related to line AB? Well, students, hopefully you can see that right away. They're perpendicular. Okay? So how is line L related to line AB? They're perpendicular. Okay? So pretty simple. They're perpendicular. Now, also, sorry, it's perpendicular and also, hold on one second, students. Also, it bisects it too, because this segment here is congruent to this segment here. Okay, sorry about that. So perpendicular bisector. Now, as an opposing player with the puck approaches the goalie is likely to move from line L to other positions, which makes sense. If the guy's over here with the puck, the goalkeeper's not going to stay over here. He can if he wants, but he's going to get scored on, okay? So, if you were the goalie, what would be the relationship between angle APB, so this angle here, and segment array PG, right here? Well, to be honest with you, students, it's pretty obvious to me. And by the way, this is true. I have played goalkeeper before in soccer, and you're taught to mentally, when you come off of your line here, you're taught to mentally draw a line from the center of the goal to the point of attack. So if the guy's here, you want to come out to a certain extent on this line. And this line here is always going to bisect the angle. Okay, so it's going to be an angle bisector. So that's the answer. What's the relationship between ray PG and this angle right here? PG is an angle bisector, okay? Now, and then by the way, just to talk soccer for a second, if the person is way over here, then of course the goalie would get in the near post right here. Okay, but beside the point, the main thing they want you to see is this line right here. If the goalie is where he's supposed to be, it's going to bisect that angle. Okay, bisect it. Okay, moving on to number 27. How does angle APB change as the puck gets closer to the goal? Okay, well, I mean, think about it, guys. As the puck gets closer, like if the puck's here, look how big the angle is now. Okay, the angle's getting bigger. So, how does angle APB change? It gets bigger. It increases as the puck gets closer to the goal. Now, does the change in the angle make it easier or more difficult for the goalie to defend the goal? Well, again, students, that should be common sense. Anytime the person with the puck gets closer and closer to the goal, it's going to be more difficult for the goalie to defend the goal. So the first answer is, as the puck gets closer to the goal, this angle right here is going to get bigger. And then secondly, it becomes more difficult for the goalie to defend the goal. Okay, so that would be, as C below, that is the answer. Okay, so let's go over that again. The angle as the puck gets closer is going to increase, okay, and it will become more difficult for the goalie to defend the goal. Okay, all right, moving on to number 28. Okay, we're going to do a proof here. Okay, so here we go. Okay, students, here we go for number 28. And this is going to be a pretty tough proof, so I'm not going to spend a lot of time on this explaining everything that I do, but hopefully it'll make sense, okay? Now here's what we're trying to do. We are told the first thing you do, students, is always pick up your given and put it on your picture. So we're told that AC is perpendicular and a bisector of BD. So AC is a perpendicular bisector, so there's a right angle here, and we have that marked, and this segment here is congruent to this segment here because this is a perpendicular bisector. In other words, AC cuts BD in half. So I'm going to put a slash here and a slash here. Now we're trying to prove that this triangle here, ABE, is congruent to ADE. That right there. Okay, so here we go. Let's go ahead and do this. So students, the first thing we're going to do is we're going to list out our given. So here's our, let me change colors here so we can see it a little better. So here we go. So my given, okay. All right. Now, next, look what I can say next. Here's where it gets really difficult to see, but if you'll take some really good notes on this and listen, I think you'll understand this, okay? This is a really, really tough proof. AD is congruent to AB. Now you say, Mr. Earhart, how do we know that? Okay, let's come over here and mark that, okay? So AD is congruent to AB. There we go. Now, how do I know that? Look at this carefully. This is so cool. Watch this, okay? It's the perpendicular bisector theorem. Okay? Now here's what I mean by that. Look, we learned that if a point lies on a perpendicular bisector, and Mr. Earhart, how do you know that line AC is a perpendicular bisector? It's in your given right here. It was given to you, okay? So if we learn that if a point lies on a perpendicular bisector, which point A does lie on the perpendicular bisector. If it lies on the perpendicular bisector, then we know that it's equidistant from the endpoints. So we know this segment here is congruent to this segment here, okay? Okay, students, now moving on. Next, look what else we can state here. We can state that BC is congruent to CD. Now, we already had that marked over here, okay? But we never stated that BC was congruent to CD. Now, we can state that because of definition of perpendicular bisector. There we go, okay? We're told up here that AC is a perpendicular bisector, so we know that this segment here is congruent to this segment here, okay? Now, look what we can put next. Number 4. AC bisects angle BAD, okay? Now, here's why. This is a really tough proof, but watch this, okay? Here's why. It's the angle bisector converse. Now let me explain, okay? Watch this carefully. Remember, if, and watch this carefully, we learned the other day, students, that if a point right here lies on the interior of an angle, here's your angle right here, okay, and this point is equidistant from the side of the angle, and look at this, this is congruent to this, then this here has to be an angle bisector. So that's how we know that AC is an angle bisector, okay? All right, so moving on. Next, we can write this. Angle BAE. Now again, this is a tough proof, and I know that, but you can at least write it down and follow, hopefully, the steps that I'm doing. It's congruent to angle DAE. Okay, so here it is. BAE, this angle here, is congruent to this angle here, DAE. So this angle is congruent to this angle. Now, how do I know that? Because look, guys, I just said in my last step that this segment here is an angle bisector. I just said that right here. So, if AC is bisecting this big angle here, then I know this angle here has to be congruent to this angle here. And the reason would be definition of an angle bisector. Okay? All right, moving on to number 6. Now, here we go. For step 6, we can say this. I'm going to go ahead and mark this up here real quick. So this is congruent to this. Now, this next step, this is so cool. Watch this, guys. I can say that AE is congruent to AE. Okay? And of course, that's going to be the what? The reflexive property. So I can put 3 marks here. Now look at this, guys. Look. I have this triangle here. I'm going to draw this triangle here off to the side, okay? Here it is. And I'm going to draw this triangle here off to the side. Okay, so here it is. Like this. Now, I have this angle here congruent to this angle here. I have this side here congruent to this side here. And then notice the two triangles share this side here. So I have this side here congruent to this side here. So look what I have, students. I'm done. I can state that in step 7, I can state that triangle ABE is congruent to triangle ADE. And that's by side, angle, side is congruent to side, angle, side. So my reason would be side, angle, side, okay? Pretty tough. That's a really, really tough proof, but a good one, okay? A good thinking problem. Okay, let's move on to number 29. Number 29 is to prove theorem 5.2, okay? The perpendicular bisector converse. Okay, let's go ahead and draw our picture. If a point is equidistant from the endpoints of a segment. So, draw your segment, put a point up here, and then draw your line. There we go. So, let's call this A, B, and C, okay? Now, having said that, it's given that the point is equidistant from the endpoints. So, I know that the segment here is congruent to the segment here. So for my given, I'm going to put given AB is congruent to AC. Okay? Now, the then part is my proof part. So I'm going to prove that the point lies on a perpendicular bisector. So I'm going to have to prove that. I'm going to go ahead and draw a line real quick here, okay? And let me say this right now, students. It is true. Now watch what I do here. This is very important you see this. I can draw a line like this, okay? And I can move this line. I didn't want to do that. Didn't want to do that either. Students, I can take this line here, I can move it like this, here or here. So is it not possible to draw this line so that it's perpendicular? Sure it is. So I'm going to draw a line here, okay, so that it's perpendicular, and I'm going to call that D. Okay, so I'm going to try to prove that AD is a what? Perpendicular bisector. Okay? And so here we go. Alright. Now my goal is this. I already have drawn a line here so that it's perpendicular. So if I want to prove that AD is a perpendicular bisector, I already know that it's perpendicular just by how I drew the line. But if I want to prove there's also a bisector, then I must prove that this segment here is congruent to this segment here. I have to prove that, okay? So, the only way to really do that, students, is to prove that this triangle here is congruent to this triangle here, and then I can state that this segment here is congruent to this segment here, okay? So with that in mind, here we go, okay? Here's what I'm going to do. First of all, I'm going to state my given. Okay, so AB is congruent to AC, okay? That's given. Now watch what I state next. Watch this carefully, okay? Next, I'm going to state that AD is perpendicular to BC. How could I state that? Because through a point not on line, that's point A, not on BC, through a point not on line, there exists one perpendicular line. Okay? So I know I can draw a perpendicular line. I've done that. Okay? Now, next, I'm going to state that I call this 1 and 2. Angles 1 and 2 are right angles. Okay? Because perpendicular lines form right angles. Okay? Next, I can state they're congruent. Because right angles are congruent. Okay? Now next, if you'll watch this carefully, students, look what I have here. For number 5, step 5, I'm going to state this. AD is congruent to AD. Okay? Reflexive. But that really doesn't seem to help a whole lot because look what I have. Look what I have, guys. I've got side, side, angle congruent to side, side, angle. And we can't use this. But hold it, maybe I can. Remember, when you're dealing with right triangles, you're allowed to use hypotenuse leg. And look, I have the hypotenuse of one right triangle congruent to the hypotenuse of the other right triangle, and I have a leg congruent to a leg. So I can definitely state these two triangles are congruent, okay, by this reason right here. Hypotenuse leg. Okay? I'm going to show that to you again just a second here. Triangle ABD is congruent to triangle ACD. Okay, here it is again. Here's one triangle. Here's the other triangle. Okay? Now we have a right angle and a right angle. We have this side here, right here, and this side here marked congruent. Okay? Well, the two triangles both share the side here. Okay, so I know this side here is congruent to this side here. So there it is. I have the hypotenuse of one right triangle congruent to the hypotenuse of the other right triangle. I have a leg here congruent to the other leg. So the two triangles are congruent. Now that I've stated that the two triangles are congruent, then I can definitely state that BD is congruent to DC. Okay? And the reason would be CPCTC. Now, guys, we're one step away from finishing this. Look at what you're trying to prove. You're trying to prove that AD is a perpendicular bisector. So I can definitely state that AD is a perpendicular bisector. And I can state that because of definition of perpendicular bisector. Because look, students, I already stated that I have right angles here, so I know it's perpendicular. And I just stated up here in step 7 that this segment here is congruent to this segment here, so I know AD is also a bisector. Okay? So with all of those things in mind, I can definitely make this last statement. Okay? All right, moving on to my next proof, theorem 5.4. All right, here we go. All right, here we go. If a point is on the interior of an angle and is equidistant from the sides. So here we go. Here's my angle. Okay, here's my point. And I'm going to go ahead and draw these lines in such a way that there's a right angle here, which I can do that, okay? There we go. And let's call these points A, B, C. Okay, there we go. So my given is, if a point is in the interior of an angle, which it is, and that point is equidistant from the sides, so I know that, we'll call this D. I know that BD is congruent to DC. Okay, there we go. Then, here's the proof part, then I have to prove, let's go ahead and draw a line here. I have to prove that AD is an angle bisector. Now the only way to prove that, students, is to prove that this angle here is congruent to this angle here. Okay? So, with that in mind, what I'm probably going to have to do is prove that this triangle here is congruent to this triangle here. And then once I prove that, then I have to prove, then I can state that this angle here is congruent to this angle here. Okay? And then I can state that AD is an angle bisector. Okay? So here we go. So students, here we go. First of all, I'm going to list out my given. Okay? So I know that BD is congruent to DC. Okay? Now next, I can state that AD is congruent to AD. Okay? And we're going to call that the reflexive property. Okay? Now, I'm going to very quickly, students, draw these two triangles up here, I think, so that we can see them a little better. Okay, there's one triangle. Here's the other triangle here. Okay, now look what I have, students. I have a congruent line here, a congruent mark here, and one here. So one here and one here. And then the two triangles share this side here. So I can put a slash here and a slash here. Now the only thing left for me to do is I'm going to number these angles 1, 2, 3, 4. The only thing left for me to do is to state that 3 and 4 are right angles, okay? Now I can do that, and here's why. Watch this carefully. Angles 3 and 4 are right angles. And I can state that because, listen carefully, remember we learned the definition of a point to a line. Whenever we say find the distance from a point to a line, we're saying that line has to be perpendicular. Okay? So just by saying the distance from the point right here to the sides of an angle, these two lines here, this line here and this line here, have to be drawn perpendicular. Okay? So angles 3 and 4 have to be perpendicular. Now, once I state that these two angles are right angles, then I can state that angle 3 is congruent to angle 4, okay? Because right angles are congruent. Okay? Now, look what I've stated, guys. I can now easily state that triangle ABD is congruent to triangle ACD. Because look, guys, once again, I have a right triangle, a hypotenuse congruent to a hypotenuse, a leg congruent to a leg. So I can say HL is the reason these two triangles here are congruent. Okay? Now, having said that, I can definitely state that angle 1 is congruent to angle 2 by CPCTC. And then lastly, students, look, as soon as I state that this angle here is congruent to this angle here, then I can definitely state that AD is an angle bisector. Okay? By definition of an angle bisector. Okay? So there we go. Again, not a super easy proof, but that is how you would do that, okay? All right, moving on to numbers 31 through 34. Okay, students, the directions say that we have these three ordered pairs right here, okay? So I'm going to go ahead and plot those very quickly here. Okay, and here we go. 1, 1 is 1 point. Okay. Over 7 and up 4, so about right here is point D, and then over 3 and up 6, so 1, 2, 3, 4, 5, 6, over 3, about right here. Okay, so I'm going to go ahead and put C here, D here, and E here. Okay, there we go. Now, plot the points, and we've done that, and sketch the perpendicular bisector of CD. So here's CD right here. There's CD. Now they want us to sketch the perpendicular bisector, so we got to find the midpoint and then draw the perpendicular line. So there we go. So there we just sketched a perpendicular bisector. That means this segment here is congruent to this segment here. Okay? Very good. Now, moving on, find an equation of, at which point does the bisector intersect CD? So let's call this point here Z, I guess. So we'll call this point Z right here. Where is that point? Okay? What is this point right here? Well, students, we should know that. I mean, look, we've learned how to find the midpoint between 2 points. Here's point C right here. 1 and 1. Okay. Here's point D right here. To find the midpoint, remember what to do, guys? X plus X divided by 2, comma, Y plus Y divided by 2. That's how you find the midpoint. So, X plus X, 1 plus 7 would be 8. Here's your X. Here's your X. 1 plus 7 is 8. Divided by 2 would be 4. Then here's your Y right here. So we have y plus y, 1 plus 4 would be 5. 5 divided by 2 would be 5 over 2. So there's your midpoint. And another way to write that, students, would be 4 comma 2.5, because 5 over 2 is 2.5. Now let's see if that makes sense, okay? Let's go over 4 and then up 2.5. That's just about perfect, right in the money, okay? So here's the ordered pair of the midpoint, okay? I'm going to sketch that real small here. So 4 comma 5 halves, okay? All right, very good. Now the next part of number 31 says find an equation of the perpendicular bisector. Okay. Now, remember, students, listen to me carefully. In order to find an equation, we need what? Two things: slope, we've learned this before, and a point, correct? Now, we're trying to find the equation of this line here, correct? And we do know a point that falls on that line. Here it is. However, we don't know the slope of this line. But hold it, students. We do know that perpendicular slopes are negative reciprocals. So if I could find the slope of this line, I could then take that slope, I could flip it, and change the sign, and that would be the slope of this line here. So with that in mind, watch this. Let's find the slope of CD real quick, okay? So here we go. Here's C, 1, 1. Here's D, 7, 4. How do you find the slope? Well, y minus y and x minus x would be negative 3 over negative 6. So a positive 1/2. So there, the slope of this line here is 1/2. So if you take that and flip it and change the sign, the slope of this line here would be negative 2 over 1, or just negative 2. So now we know the slope of the line we're looking for, negative 2. Now, real quick, students, now using this, we should be able to find the equation of this line right here. Okay, so let's go ahead and do that. So students, here we go. Where the y is, I'm going to put 5 over 2. Where the m is, I'll put negative 2. Where the x is, I'll put 4. And then we're going to solve for b, okay? So here we go. 5 halves equals negative 2 times 4, negative 8, plus b. Now remember, students, 5 over 2 is the same thing as 2.5. Okay? So when I bring this negative 8 over and make it a positive 8, I have 2.5 plus 8, that's 10.5 equals b. So there we go. Look, students, I know what the slope is. I know what the y-intercept is, b. So I'm ready to write my linear equation. Here it is. Y equals negative 2x plus 10.5. So there we go. We did it. Now I think their answer, they used 21 over 2 right here instead of 10.5. And that's totally fine. This is fine also, okay? Whatever you want to do there is up to you. But here's the midpoint. Okay, so we found that. And then here is the linear equation. A lot of work, but it's really good practice, guys. It's really good practice of algebra, and it's also taking geometry and algebra and kind of putting them together and letting you practice, okay? All right, number 32. Let's see what we have here. Number 32. Does the perpendicular bisector pass through E? Well, that's a really good question. Now watch how I'm going to solve this, okay, students? Please watch carefully. Does the perpendicular bisector of CD pass through E. Well, here's the equation right here. Here's the equation of this line. Okay? Now, here's point E right here, 3, 6. Now, students, listen. If 3, 6 truly lies on this line right here, which it might, my drawing is not the best. If it does, then this point right here should satisfy this equation. So let's see if it does. Where the y is, I'm going to put a 6. And where the x is, I'm going to put 3. Now let's see if I get out a true or false statement. Here we go. 6 equals negative 6 plus 10.5. Okay? Well, there's no way that negative 6 plus 10.5 equals 6. Negative 6 plus 10.5 would be 4.5. So, did I get out a true statement? No. Does 6 equal 4.5? No. So, does this point here lie on this line here? No, it does not. No, definitely not. Okay, number 33. Label the midpoint of CD as M, okay? Now, we called it Z earlier, so we're going to change that to an M, okay? So here we go. M. Okay, there we go. Now, is angle CEM congruent to DEM? So it's this angle here, CEM, congruent to angle DEM. No, it's not. Guys, no. And here's why. No, because point E does not lie on the what? Perpendicular bisector. So no, this angle here, CEM, is not congruent to this angle here. Okay? Because again, point E does not lie on the perpendicular bisector. Okay? All right, moving on. Let me get rid of these lines over here real quick. Okay, now moving on to the last step. Okay, so this will be good here. Find F, and F is 0, A. So, now watch carefully. F is 0, so we know it's somewhere on the x-axis, okay? A, so that EF is parallel to CD. This is going to be interesting. Watch this, okay? Look, we know that F has to be somewhere around here, okay? If we want, look, if we want, how did you know that, Mr. Earhart? Because look, if we want EF, and here's EF right here, to be parallel to CD, then I know F has to be somewhere here. Now, how did I know that F lies on the y-axis? Because of this 0 right here. I know that F has to be at 0 on the x-axis and then up a certain amount. So here's what I'm going to do. Think about this, guys. It's not that hard. What does slope equal? Slope equals y minus y over x minus x, correct? Now, if I want this line here to be parallel to this line here, what was the slope of this line here? 1/2. So what's the slope of this line here? 1/2. So where M is, I'm going to put 1/2. Now, I do have 2 points. One point is 0A. The other point is E, which is 3, 6. So look what I'm going to do. Y minus Y. A minus 6. X minus X. 0 minus 3. Now, students, 0 minus 3 is negative 3. Okay? Now, we've learned this back in middle school. Whenever two fractions are equal, like these two fractions are, we can cross multiply. So I can multiply 1 times -3, and I will get -3. Okay? I can multiply 2 times a minus 6, and I can get 2a minus 12. Because 2 times a is 2a, and 2 times -6 is -12. Now, bring the -12 over, make it a positive 12. Okay, and we will get 9 equals 2a. Now divide both sides by 2, and we will get 4.5 equals a. So students, if a equals 4.5, here's a right here, then my ordered pair would be 0, 4.5. Okay? Now I think for their answer they have 0, 9/2. But of course, don't forget that 9/2 is the exact same thing as 4.5, okay? So, 0, 9/2, okay? All right, moving on. Okay, these are pretty simple, so we're going to go pretty fast, okay? Okay, let's find the length of SU, okay? SU. Well, look, students, this segment here has 1 mark, so it's congruent to this segment here because it has 1 mark. Okay, students, so because this segment here is congruent to this segment here, then I can write 3x plus 1 equals this segment here, x plus 3, okay? Now let's solve for x. Bring the x over and make it a -x. Bring the +1 over and make it a -1. And I'm left with 2x equals 2. Now divide both sides by 2, and you're left with 1. X equals 1, okay? So, if x equals 1, then where the x is here, I'm going to put 1. So 3 times 1 plus 1 would be 4. Okay, so this whole length right here is 4. So this length here is also 4 right here. Okay, right here. So students, the answer to 35 would be 4, which is F. So there we go. And I'm going to cross this off, okay? Now, there we go. Next, number 38 here, the length of WT. Now that's this length right here. Now students, I understand that from here to here, the length is 2, okay? But look at this. This triangle here, right here, is congruent to this triangle here. And let me show you how I know that. Okay, watch this carefully. I have a right angle here, so I have a right angle here. So I have angle, 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 side, right here. They share a side, okay? Angle, 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 side, congruent to angle, angle, side. So if these two triangles are congruent, then this segment here, this side here would also be congruent to this side here. And we just learned that this side here is 4. So this side here is 4. So this side over here is 4. So the whole segment would be 4 plus 2, which is 6. Okay, so the answer to number 38 would be 6. Letter D. Okay? Now, moving on to this. Angle VWX. Okay? This angle here. VWX. Now watch this carefully. This angle right here. Okay, now watch this. I know this is 90 right here. Okay. So 90 plus 50 is 140. So I know this angle here has to be 40. So this angle here has to be 40. Okay, so VWX would be 40, letter C. Now, moving on to this one, angle XTV. Here's X right here. No, down to 36, sorry, 37, down to 37 here. Angle WVX, okay? So W, then V, and then X right here, this angle. Well, obviously that's going to be 50 degrees, okay? So there we go. So the answer would be E, 50 degrees. Now, students, whenever you're taking tests, and you can save time in the end, always try to do that, okay? Look at the last two angles that they want us to find. They want us to find angle XTV. So XTV, this angle here, okay? And then angle XVT, okay? There we go. Well, students, look, there's only two answers left, 60 and 30, okay? And it's very obvious which answer is bigger, okay? And so, or which angle's bigger. So this angle here would have to be the 60 degrees, and this angle here would have to be the 30 degrees. Now, students, that's not the most geometrical way to do that, but it is the fastest way, and it's the most common sense way to do that, okay? So this angle here would be 60, which is letter A, and this angle here would be 30, which is letter B, okay? Alright, guys, I hope this homework video has been a help to you guys. Call or email if you have any questions.